In this video, we're going to take a look at the relationship between periodic trends and single replacement reactions. Single replacement reactions are going to only spontaneously proceed in one direction. Let's look at these two related reactions to try to see if we can apply what we know about periodic trends to figure that out. When analyzing a single replacement reaction, look at the single element that is listed and decide whether it is a metal or a nonmetal. The element in this reaction is fluorine, which is a nonmetal. So in a single replacement reaction, nonmetals will replace other nonmetals. So this is a switch between fluorine and chlorine. To decide whether the reaction is possible or not, we're going to make a comparison between those two elements, fluorine and chlorine, to see which one is more reactive. Now, if we had a reactivity series handy, we can use that to decide which one's more reactive. But since we don't have one handy, we're going to use what we know about periodic trends. By looking at the placement of fluorine and chlorine on the periodic table, we can see that fluorine will have one fewer shell of electrons. What this is going to do is it's going to provide greater attractive forces for gaining electrons. And so fluorine is going to be the more reactive too because of the smaller distance by having fewer shells. So, of the two reactions above, we have, in the first reaction, we have fluorine replacing chlorine, and the second reaction we have chlorine replacing fluorine. Of the two, the one that's going to happen is the one where the more reactive gets to react and get into a compound. And so the top reaction is the one that's possible, and the bottom reaction will not happen. As our next example, let's consider the reaction between sodium chloride and magnesium to see if the reaction is possible or not. Now, our single element, magnesium, is a metal, and it will react with the sodium chloride to replace the sodium. So our comparison is going to be between magnesium and sodium. As we compare magnesium with sodium, since they're both metals, we're looking for the element that is most likely to lose electrons. The element most likely to lose electrons will wind up in a compound at the end of the reaction. So as we take a look at them on the periodic table, we can see that sodium has one fewer proton than magnesium. By having the one fewer proton, sodium is going to have weaker attractive forces to hold on to its electron, and sodium is more likely to lose electrons. Therefore, the reaction that we have written above will not take place. Let's look at one last example. In this reaction, we have chlorine possibly replacing iodine. Chlorine and iodine are nonmetals, and since they're nonmetals, we'll be looking at their ability to gain electrons. Whichever one is better at gaining electrons is the one that's more likely to wind up in a compound at the end. Here we find them on the periodic table. From their placement on the periodic table, it turns out that chlorine will have fewer electron shells, and thus the distance to the nucleus will be closer for chlorine, and that means chlorine is going to be the better able to gain electrons. Turning back our attention to the reaction from above, we can see that chlorine, the more reactive of the two, does wind up getting to be in a compound at the end, and so this reaction will take place.